This conference will now be recorded.
Hey, hi everyone, welcome to Isha Training Solutions. So guys, we'll wait for 2 more minutes. We'll wait for 2 more minutes for other learners to join, and then we'll start our discussion. 2 minutes we'll wait, and then we'll start our discussion, guys. Thanks for joining the session. We'll wait for 2 more minutes, and then we'll start our discussion, guys. Thank you. Once again, welcome everyone. Welcome to Isha Training Solutions. Thanks for joining, guys. So yesterday we discussed about the course content, basically, what we are going to cover in this course journey, like that. So today we are going to start the actual topic, day one. Day one topic we are going to start. So I encourage each and every one of you, please stop me at any point of time. Whatever the doubt that you are having, you can ask me, and then we will move on, guys. Okay. So actually, the first topic, introduction topic. Uh, yeah. So introduction to performance engineering. Introduction to performance engineering. Okay. So why we are having this topic, because right now that clarity is actually missing. That clarity is actually missing. Say like uh, performance testing, everyone knows. Okay, I mean, most of you aware like what is performance testing, but performance engineering side, maybe we don't have that clarity, or the clear cut understanding is actually missing. Okay, so performance testing means basically what we are doing. Okay, anyone can say what is performance testing, what we are doing it in performance testing.
So in
Basically,
performance
basically,
test,
Yeah, one at a time, guys. Chakravarti, you can ask, you can tell your answer.
okay. So basically, testing the application based on the user load.
Okay, very good. Yeah, GK, you can tell your answer.
yeah. So performance testing, basically, what we do in performance testing, we ensure the capacity of application, we ensure the performance bottleneck of the application by putting the different sort of loads on the application, and then we monitor the different performance parameter like how the resource utilizations are happening on the different load, and what is the maximum capacity that application can support, and whether the application is able to meet the business SLA or not. So those sort of things we validate using performance testing.
Yeah, very good, GK. So actually, yeah. So performance testing is nothing but checking the stability of the application under various workload conditions. Okay, so you are testing, that's all. You are testing and under different workload condition, and you are commenting about the stability of the application. But engineering is little above. Okay, you are going little above. I mean, where you have room for improvement, finding the root cause, optimizing, fine tuning, compressing, minifying certain things. So engineering is nothing but you are going on the optimization path. Okay, testing will, yes, testing to an extent it will say the problem. Okay, it will say a problem, but engineering is little about that. Engineering is actually going to say where the problem is, how to identify or how to resolve it. That is where the engineering concept is actually comes into picture. A typical example is performance testers. Performance testers, when they are testing a functionality, okay, any functionality, a performance tester when they are testing. Example, they are saying after testing, they are saying search transaction is actually taking 15 seconds. Search transaction is actually taking 15 seconds. So performance tester, they'll stop there. Probably they have a very limited visibility into the application. So basically they'll say search transaction took 15 seconds, or purchase transaction took 10 seconds, like that. They'll only say the number, and then they'll leave basically, because they have that kind of a visibility only available. But performance engineers, they are going little above. Performance engineers, they have to understand, yes, search transaction is actually taking 15 seconds, means where it is actually taking 15 seconds. Is it actually on the application server? It is actually on the DB server, where the actual time is actually consuming. Or if the time is actually consuming in application server, or if the time is consuming in database server, what I have to do to reduce the timing, optimize that performance? Is there any component or the logic that I have to change it, or in a way that I'm retrieving the data from the DB, I have to change it, in a way that I'm handling the test data, that I have to change it? All those things are actually comes into the engineering scope. Okay, so performance testers, yes, to a certain extent they'll only say yes, there is a problem, but engineers are going to do little more detailed detailed task they are going to do. That's where I'm talking about whether it may be a client side analysis, or server side analysis, or DB side analysis, or infra side analysis, or network side analysis. Yes, you can focus on each and every layer and try to optimize your application performance. There the engineering concept is actually comes into picture. There performance engineers are actually going to do that task. And one more thing also, it may be a layman understanding I'm saying. See, nowadays customers are expecting uh, I'm expecting very detailed information only. Say, example, you are publishing one performance testing report to your customer. You are simply publishing a performance testing report to your customer. The customers, if you are saying very high level information, they are not actually interested nowadays. They'll say, boss, this can be, anyone can provide this number. That is what I mean. Usually nowadays, that the expectation from the customer is actually high. The same example whatever I quoted, right? So search transaction is actually taking 15 seconds. Search transaction is actually taking 15 seconds. Example, Chakravarti is my development team lead, or Chakravarti is my customer side. I'm doing a performance testing. Okay, I'm doing a performance testing. Say like I'm a performance tester. I spent 5 days for requirement gathering, at least collecting all the informations, and then I spent 1 or 2 days for preparation of the test plan and strategy, and I spent 3 to 4 days for preparing the scripts. Then I spent 1 or 2 days for the execution. Then I spent 1 or 2 days for the preparation of the report. I spent almost 20 days. Almost 20 days I spent, and then after 20th day, I'm coming and telling it to Chakravarti, search transaction is actually taking 15 seconds. search transaction is actually taking 15 seconds. What response usually Chakravarti will give, when at this situation, if I'm saying search transaction is actually taking 15 seconds, the reaction from the Chakravarti is, boss, if you are coming and telling me search transaction is actually taking 15 seconds after 20th day, this is not fair. Because I know using the stopwatch, simple stopwatch, day one I can say search transaction is actually taking 15 seconds. Day one I can say search transaction is actually taking 15 seconds using stopwatch. What differently that you are going to do? What additional information that you are going to give it to me? What is the value add that you are giving it to your report? That is a question nowadays everybody they started asking. In that situation, the answer is you should know about engineering concept also. You should know about engineering concept also. If you are simply saying I will only do testing activity, nowadays many customers they are not interested. If you simply say that I will only do performance testing activity, they are not interested at all. Because the trend is actually changing. Nowadays, everybody is expecting you need to provide a detailed information about the problem statement. At least a value add information about the problem statement. Okay, so that is the expectation in the industry right now. So that is the reason we all are gathered here. We are going to learn performance engineering concept so that we are going to use that knowledge in our day-to-day work to do the application optimization and all. Okay, that is also one of the reason. And one more thing. So in my personal experience, I'm saying when I crossed probably 6 years, 7 years experience level, when I crossed 6 years, 7 years experience level, my manager, he started asking me, you are now 6 years, 7 years experienced guy, and you are simply saying, I will only do script preparation and execution means, no, this is not the expectation. This is not the expectation. You are a senior guy. You are a senior guy. Now you are simply doing scripting and execution. This is not acceptable. Scripting and execution can be done by even 1 year, 2 year experienced person also. So for your experience, you need to provide more information, more value add, more data that you have to provide. So that is the expectation for your experience level. So try to learn a lot of engineering concepts and then contribute. That is the word provided by the manager. So why I'm saying nowadays the expectation is actually completely different. After 6 years, 7 years experienced level, you are not going to only do scripting and execution. The expectation is completely different. You need to provide a little more information to the stakeholder. That is what the trend now, guys. That is what the trend now. That is the reason in certain organization they are giving you the job role itself, performance test engineer. They are giving the job role itself, performance test engineer. No more they are calling you as a performance tester. They are calling you as a performance test engineer because their expectation is you need to do certain engineering implementation as well. Capacity planning, optimization, fine tuning, minification, identifying the problem, root cause analysis. All those things are the expectation from the client nowadays. So you cannot simply say I will only do script preparation and execution. You should do little more than the expectation. Okay, that's where the importance of performance engineering is also comes into picture. Okay, so now what I told you, the testing will only test the application. Engineering is actually going to provide you little more information about optimization, fine tuning, all those things and all. Testing is actually a high level information. Engineering is actually the detailed information. That is also we should know. And testing will probably for first few years in your career journey, maybe you can say I know this alone, but over the period of time, you cannot simply say I only know scripting and execution and all. There you need to know certain engineering concepts as well. That is the expectation. That is the expectation. I'll take a pass here, guys. Any question till now? Yeah. So that definition is important, guys. Nowadays, most of the organization, yeah, your name is actually mentioned as N. N, you can ask your question. Yes, please.
Hi sir. So actually, I wanted to ask, this course will also cover for the application like performance engineering of .NET application, or it is relevant for means it is a generic course that will help if someone is doing a performance testing and engineering on .NET applications.
See, this will definitely help you covering all the things. I'll tell you in what way we designed this course content basically. See, see, when we are adding, keep on adding things, the length of the course will become bigger. Okay, so now it is actually 25 plus hours. So if you are adding something on application side, something on database side, something on infrastructure side, the length of the course will become lengthy. So that is the reason we restricted ourselves with the Java alone, because maximum coverage is actually there in the Java itself. That is one thing. And one more thing, except that part which is the Java and .NET part, right? The other things like database concept or infrastructure concept or client side concepts and all, it is all common across the stack. It is not going to talk about .NET, Java and all. It is a common stack. So only place where the Java and .NET is actually coming your application level, and in that also whatever the knowledge that we are going to gain in the Java learning, right? Similar kind of a learning only will be there for .NET also. There also garbage collection, there also heap dump, there also thread dump, all those things are actually there. So only the naming conventions would be little different. Other than that, quite a similar activity only you are going to do it in .NET as well. So whatever the learning that we are getting it in the Java, you can actually get the similar kind of an understanding in .NET as well. Only thing is, if you are keep on adding stuffs, it will increase the length of the course. That is the reason we restricted the thing to Java alone. Yeah. Okay.
Yeah, sure. Thanks, sir.
Yeah, sure.
And hey, hi, this is Naga Krishna. Actually, I joined today. Yesterday I didn't join. So I just gone through the course content and I have a couple of doubts. So one is it is mentioned production log analysis, right, in the course content.
Hmm.
So how do you? I mean, are you using any tool to do the production logs? I mean, how do you cover the topic? Um,
Yeah, so there is a tool called Log Viewer. Okay, there is a tool called
log
Log
view.
Viewer. Through that we can analyze it. And there is one more tool called AWS Stats, which is available as well. So that tool. And apart from that, you can still use Google Analytics. Okay, Google
Okay.
Analytics. So there is a learning version. I mean, a demo version of the Google Analytics is actually available over the internet. So that also you can look into. Even Adobe Analytics is actually there, but Adobe Analytics they are not providing any demo. But Adobe Analytics is also one such tool, and other APM tools like Dynatrace is there, AppDynamics is there. All those things are there. But we are going to use this Log Viewer tool, and we are going to see this Google Analytics version, and we will also see the AWS stats as well, Nagakrishna.
Okay. Thank you.
Yeah, sure. Yeah, Chakravarti, you can ask your question.
Yeah, this is a generic question, which is almost similar to the person initially who asked. So, when you say Java or .NET specific performance engineering, how much is that necessary to know this Java programming language or .NET programming language? I mean,
See,
is it
that's
compulsory to know those?
yeah, good question, Chakravarti. So I'll tell you. So it's a journey, guys. Okay, for a benefit of everybody, I'm saying it's a journey. Okay, so you wanted to contribute where? Okay, the decision is like this, right? You wanted to contribute where? You wanted to contribute in the application level, DB level, infra level. Those are the first decision making. And then where you are right now, there you are going to contribute first. That is a common thing, right? Where you are right now, the example, you are being a performance tester, you wanted to move to the performance engineering, means there you will contribute. That is for the first step. But over the period of time, it's a journey. Over the period of time, you wanted to learn additional database knowledge or additional infrastructure knowledge or additional network knowledge or additional application knowledge. That time only this learning language and all is actually comes into picture. It is not mandatory that you have to learn the language day one, then only you become a performance engineer. No, it is not like that. But over the journey, if you are learning that, it is actually a boost your career, or learning ladder, it is actually going to boost. So in that journey, yes, you can learn and add a value, that your engineering career you are going to add a value. But it is not a bare minimum criteria to become a performance engineer. You can contribute in other layers also. Okay, without even touching this actual thing, you can even contribute in other layers as well. But your interest to learn things, and over the period you wanted to learn the language skill also, yes, you can learn, and you can be a adding that as one of the criteria to be a performance engineer as well. But it is a lengthy journey. Right now we are starting with at the point, and over the journey, if you wanted to add value to your learning, yes, you can learn the Java and all, but it is not a prerequisite to become a performance engineer. Okay.
Thank you. Thank you very much.
Yeah, sure. So coming back to the course content, so actually performance engineering, that is what we don't want to go to the negative mindset always, that I should know this language, that language, like that. No, engineers can contribute in wherever possible. You can contribute, that is a step to go. But over the period, you can learn certain things, learn new tools, learn new concepts, learn certain features, certain best practices, and then you are going to add value, and then you are going to additionally contribute. That is what the expectation. Okay, that is the reason we are going through this course journey itself. Okay, so engineering activities, yes, in the upcoming topic, I am going to explain about what are all the things that are required, or what are all the places that you will contribute as well. All the things we are going to discuss, so that you will get an idea. Okay, these are the places that we can contribute, these are the things that we have to learn right now, where I am standing, and what are all the things that I have to add value. So those things and all we are going to discuss in the subsequent topic, guys. So that is how we are going to cover the introduction part itself. Okay, that is one. The next topic is actually performance engineering life cycle. Performance engineering life cycle, any activity people are doing, guys. Okay, any activity people are doing, they are following a life cycle. Okay, life cycle. So even I told you yesterday also the same thing. When developer, they are starting their activity, when developers they are starting their activity, they are following SDLC model, software development life cycle. Software development life cycle, SDLC. Okay, software development life cycle. Similarly, when a software tester, okay, uh, uh, post completion of the development, they wanted to do the testing, means yes, they are following STLC, software testing life cycle. Okay, software testing life cycle they are following. Once functional automation testing and all completed, when the code is actually reached to the performance testing team, they are following performance testing life cycle, PTLC they are following. PTLC they are following, performance testing life cycle they are following. Similarly, for the performance engineers also, they have set of things that are there, that they are going to follow as a performance engineering life cycle. Okay, just a minute. So performance engineering life cycle. Okay, so they need to follow certain steps. Performance engineers should follow certain steps. That is where they are going to uh, complete their activities. Okay, this steps is nothing but right from requirement gathering till capacity planning, or giving your task to the end user, right? There is a life cycle associated. Say why I am having this engineering life cycle in the course content, I'll tell you. It is for some reason only. Say like you take an example. In this forum, any performance testers are there, guys? Any performance testers?
Yeah.
Yes,
Chakravarti is there.
yes.
Yeah, yeah. So why I simply say like I'm an interviewer. I'm an interviewer. I'm going to take interview for Chakravarti or Nagakrishna, and I'm asking them, tell me about yourself or brief yourself. Okay, brief yourself, like that I'm asking this question. So basically what Chakravarti or Nagakrishna, what they will do, they will summarize their introduction, right? They will introduce what they are actually doing. Actually saying when they are summarizing, begin the screen, I'm saying begin the screen what they are doing. When they are summarizing, begin the screen what they are doing, I'll tell you. Okay, so say like I'll flip the role. Chakravarti is actually asking me, brief yourself, or Nagakrishna is asking me, brief yourself, like that. I'm going to answer. I'm a performance tester. Example, I'm going to answer for that question. What will I do, guys? Basically, what will I do? I will introduce myself and begin the screen in my mind. In my mind, what will I run? If I'm a performance tester, in my mind, what will I do? I will run the performance testing life cycle only. Performance testing life cycle only I will run it. How cleverly I will answer, I'll say, I'm Saravanan, I have so and so experience, like that I'll say. And straight away also, I have experience in collecting the non-functional requirement from the client. Either I will discuss with the client and then collect all the required details like concurrent users and throughput and all. And post collecting the requirement, I will prepare the test planning. I have experience in preparing the test planning document with the detailed information. I will get the sign off and all. I interact with the client to do the sign off and all. Post getting the planning document, I use either LoadRunner, Jmeter to do the scripting. I follow the standards and all, and I do the execution. I have experience in executing the load testing, stress testing and all. And post executing, I will prepare the report, and I'll provide a detailed report to my client, like that. In my mind, what will I run? Basically I'll run the PTLC only. If you remember, if I what I summarized, it is like test planning, test scripting, text execution, reporting. All those things are actually the life cycle for performance testing. Okay, right from NFR gathering. Okay, NFR gathering, test planning, test scripting, text execution, test reporting. This is actually the life cycle, right? So in my mind, I'm running the PTLC life cycle, but I'm providing answer to my interviewer like as if I'm the owner for everything. Right from requirement gathering till providing the report to the client, I am doing each and everything, nook and corner. I have experience. That way only I usually explain, right? So that is the reason we are learning the performance engineering life cycle also now. Why we are learning the performance engineering life cycle? Because we wanted to provide answer to somebody, or provide explanation to somebody, that what you are actually doing it in the performance engineering means. In my mind, I will run that performance engineering life cycle layers, and I will clearly explain to them, these are the things I will do, these are the things I will do, these are the things I will do, like that I'll explain to the stakeholder. I'll take a pass here, guys. Any question till now? Yeah, the silence I'm taking, that we are clear with what we discussed. So that is the reason we are learning this PELC, which is performance engineering life cycle. Performance engineering life cycle. So performance engineering life cycle. See, I wanted to have some comparative understanding. That is the reason. What I thought is that, like, why don't we compare the performance engineer's job role with developer's job role? So SDLC and then PELC. SDLC and then PELC, I'm going to simply compare and say. Okay, nothing to do with that, but simply for understanding purpose, I'm explaining that. Okay, when developers, they are doing something, what performance engineers they can focus on, right? So that is what I'm trying to tell you here. Say like the first activity, requirement gathering. When developers, okay, when developers, they are doing the requirement gathering. Okay, performance engineers also will do the requirement gathering only, but they'll say system sizing information. Okay, what I'm going to plan my system, basically how it has to be, what configuration it has to be, like that. In the initial stage, they'll collect the requirements related to system sizing. Okay, performance engineers, what they will do, they'll think about the system sizing, and they'll also think about one more thing, to right number of resources to provide satisfactory performance to the end user. Okay, I'm going to use a particular configuration which is going to give a satisfactory performance to the end user. That also a performance engineer will always focus on. What way I am going to give a satisfactory performance to the end user? Am I satisfying my end user? My end users are actually properly convinced with the way my application is actually working? Those point of view only performance engineers should think about. What are all the others they'll think about? They'll think about response time, they'll think about concurrent user, they'll think about business transaction, they'll think about growth rate, they'll think about storage requirements, because all these things are the factors which will affect your performance. All these things are the factors which will affect your performance. So the first phase is what? Requirement gathering. When the developers, they are doing the requirement gathering, what performance engineers will do? Yes, performance engineers also will think about requirement gathering only. What are all the things they'll focus on? They'll think about system sizing. What is my size of the system that I'm going to have it, and at what point I'm going to give a satisfactory performance to the end user, how my response time should be, how many concurrent user I'm going to use it, what are all the critical business flows that I'm going to use it, what is my growth rate from 1 year to another year, what are all the storage requirement that is actually be there, so that I'm not going to store too much of a data or unnecessary data that I'm going to store it, all those things. Sorry. Yeah, sorry guys. So all those things you are going to discuss about. Requirement gathering phase itself, performance engineers should gather this information. Performance engineers should think about all these information. See, as much of information when the performance engineers they are gathering only, they have a detailed understanding. Okay, so I'll tell you, actually saying, you guys can ask me a question, why this cannot be done by developers or what? Why this cannot be done by developers or what? Actually saying, developers can do it. Developers can do it in many organization. Actually developers are doing, but most of the time what is actually happening, developers are running behind timeline. Developers are running behind timeline. They always have some certain deadlines, some deliverables will be there for the developers. I'm not blaming them, that is their job nature itself. First what they will do, they'll collect the requirement and they do the development, and then they will share the code to the unit testing team, or they will do the unit testing. Once the unit testing is actually completed, they'll give it to the system integration testing. Once the system integration testing completed, they'll give the code to the UAT tester and performance tester. Once it is all done, they'll give it to the production support team. So everywhere the developers are actually busy. The developers are actually busy. Because of that, what is actually happening, they don't have time to think about this optimization, fine tuning, minification, compression, infrastructure utilization, all those things they are not actually focusing on. They are not actually focusing on. But in reputed organizations like CMM level 5 companies, top level companies, what they are doing, the developers are actually still following all these standards. They are still following all these optimization standards and all they are following. We are still following. But in many organizations, since because they are not following the standard, that's where the performance engineer job role is actually comes into picture. That's where the performance engineers, what they are doing, they are analyzing the application and they are providing their recommendations to optimize the application performance. The optimization can be two ways, guys. Okay, optimization can be two ways. One is in the early stage itself, during the development stage itself, when you are doing the optimization, that is easy, cost effective. When you are doing optimization in the early stage itself, that is easy and cost effective, because then and there you are going to identify the problem, then and there you are going to resolve the problem. Optimization can be very, very, very easy. But if you think about the later stage, nothing but you completed your development and then you are facing the problem, means that is actually a tough task, and also investment will be very, very heavy, because because that time you have to change a lot of things. You may need to rewrite certain portion of the code, or you may need to change the architecture, or you may need to change certain logic. Lot of involvements will be there during that time. So that is the reason it is good that you are doing your assessment each and every time and understand how your application performance is there, and then and there you can resolve your application bottleneck. Okay, so that is a best practice. But in industry right now, what is actually happening most of the time in industry right now, what is actually happening most of the time, they are completing the development, and then only they are realizing the application issues, and then only they are focusing on performance engineering concept. But it is very late, it is very late to focus on performance engineering concept during that time. But no other go, they have to do certain optimization to make the application to load faster or work in a streamlined way, guys. Okay, that is what in industry right now it is actually happening. But I would say that if it is actually happening in the early stage, the cost effective way you can optimize your application performance, that is the best way to do. As I'll take a pass here, guys. Any question till now?
Yeah, I have one question. So you said during the initial phase of performance testing itself, like the development itself, we need to start the performance testing, right? So do you mean that we need to do a agile performance testing? I mean, even that way, my other question is, in that way, we'll not be able to test the end-to-end testing of the application, right? Since the application might not be developed completely. So will that be
See,
effective?
say engineering cycles usually will not come in the release milestone at all. Okay, testing only will come in the release milestone. Engineering will not come in the release milestone. Okay, and answer to your thing, yes, that is the reason nowadays people are talking about shift left approach and all, right? Early performance testing, where if your end-to-end application is not ready, also somewhere we can use API level testing or some screen level testing, that you can do it and then do the analysis and all. People are trying. I'm not saying 100% is successful, but they are doing that as well. So the intention is, instead of making things move to the end and then identify the problem, try to move things little early, so that you are trying to avoid unnecessary issues, Chakravarti. That is the intention. You cannot completely do everything automated, everything completed early and all, but wherever possible you can do that, so that you are getting little benefit and you are optimizing your application performance as well. Okay.
Sure, makes sense. Thank you.
Yeah, sure. So for the learners who joined today for evaluating us, okay, this is Kumar sir number 8019952427. 8019952427 is Kumar sir number. I'll copy paste this number in the chat. You guys can take it. Okay. So this is Kumar sir number. You can reach out to Kumar sir for any further information, anything related to course timing, course content, fees related, anything you wanted to discuss, you can discuss with Kumar sir. I'll also copy paste this course content in the chat as well, so you guys can take it. This is what we are going to cover it in the course journey. And this is actually a weekday session. Monday to Friday we are going to have the session. Monday to Friday we are going to learn uh, 6 p.m. to 7 p.m. IST. Okay, 6 p.m. to 7 p.m. IST. Other corresponding timelines are actually there in the website. This is the timeline for US UK students. This is the corresponding timeline. Indian time is actually 6 p.m. to 7 p.m. we are going to learn. Monday to Friday we are going to learn. Saturday Sunday it is actually holiday. All these sessions are actually recorded. All these sessions are actually recorded. We are going to share these videos in the YouTube playlist URL. On a daily basis, we will share these videos in the YouTube playlist URL. And these videos, you are going to have it for lifetime access. You are going to have it for lifetime access. Any number of times you can watch it. Even sometimes you are unable to attend the session, you are missing any session, also not a problem. You can watch the video and then you can come back and I'll ask your questions. Okay, so these videos you are going to have it for lifetime access, and all artifacts, supporting documents and everything we are going to share it through Google Drive. Okay, so that you can download, set up everything in your local machine, learn everything in a practical way. These things we are going to cover it in a practical way, so that is the intention of it. So those who wanted to have the continuous learning, you don't want to miss anything, you wanted to have a continuous learning, please reach out to Kumar sir. 8019952427 is number. All industry best practices, okay, interview questions and everything we are going to cover it, guys. And I also told you we are going to cover a APM tool, Dynatrace APM tool, we are going to cover it. That is also a value add. And we are also covering client side monitoring, DB side monitoring, infrastructure monitoring, application level monitoring, and we are also covering two profiling tools as well, YourKit Java Profiler and Java Profiler, like that. So there are two profiling tools we are learning. So a lot of value adds are there in this course journey. So those who wanted to have a continuous learning, please reach out to Kumar sir. 8019952427 is number. We already started the session actually. Today is a day one session, but for the learners who interested to attend the evaluation session, so we opened up for the evaluation. So thanks for joining. Thanks for giving me this opportunity to share my knowledge and experience with you people. So we are going to continue the same thing. We are going to continue the same thing for next few days. I mean, this course is actually for 25 plus hours of session. We are going to learn it. This course content we are going to learn for 25 plus hours of session. We are going to learn it. So we are going to continue the same for upcoming days as well. So you wanted to have this continuous learning means you can reach out to Kumar sir and then enroll for this course journey, guys. Clear, guys? Everybody? Yeah. So with this understanding, thanks everyone for joining this demo session. Thanks for giving me this opportunity. Thanks all. Bye bye.
Thank you very much.